Welcome to Technically Speaking, where scientists and engineers come together to chat about a common interest, share knowledge, and satisfy some curiosity. I'm Antonia. Today I'm joined by Jasmin and Sophie to talk about methods of hydrogen production and why it's become a popular topic of discussion. To start off with, a little introduction from yourself, Jasmin. How is hydrogen relevant to what you do in your work?
Yeah, so I do a lot of research into decarbonisation, specifically ways of achieving net zero. And for quite a few sectors, hydrogen is going to be really important in terms of reducing greenhouse gas emissions.
I've had a look at hydrogen as well and trying to put together a few different companies' net zero strategies. And for some, there is no alternative for high temperature heat apart from hydrogen.
Yep, pretty much.
Well, I want to say widespread. Hydrogen's not widespread yet.
Yeah, it's an issue. Like currently hydrogen production's still quite limited, so scaling it up to what is needed for large scale use is gonna be an issue. But there are lots of different ways of producing hydrogen.
Yeah. Sophie, this is your first time on the podcast. Could you introduce yourself and how hydrogen is relevant to what you're doing?
So I work in the nuclear industry as a chemical modeller. One way of producing hydrogen potentially is using nuclear power plants. Yeah, I've in my team done a little bit of modelling looking at that, and really interested in how nuclear can play its role into this fuel type.
Nuclear is another, I want to say, future technology. Some people are uncertain about to what scale it will be, so it's interesting to pair something else that is kind of an uncertain thing, obviously quite a new area of research.
Yeah, I mean, I guess we've had nuclear power for, longer than I've existed. So it's not totally new, but ever-changing new technologies coming out at the moment. So it's definitely an exciting field to be in at the moment.
Why do you think hydrogen and nuclear are an interesting topic for people to research now?
So yeah, it's a really exciting time in the nuclear industry. Has been a bit of a renaissance and how we can help use it to reach net zero. So it's really an interplay between renewables, and nuclear seems to be the way forward to achieve that. Yeah, in terms of hydrogen, as we've mentioned already, there's a lot of parts of industry that are hard to move away from fossil fuels, that need a source that's not just electricity based, but also in terms of manufacturing chemicals as well. So pairing the two together and reducing the amount of carbon emissions it's interesting science, but it's also really important for the future of the world, I guess.
Jasmin, where have you seen a need for hydrogen?
In terms of like current demands of hydrogen, it's mostly in chemical production as well as in other industrial processes like iron and steel making. It's also been used a little bit in transport. So like in the early 2000s, we had hydrogen fuel cell vehicles, which kind of fell out of popularity because electric cars became all the rage.
All the rage or all the range? Because I thought hydrogen had all the range. Sorry, I had to get that pun in.
Yeah, and in future uses of hydrogen, it will be in industrial decarbonisation, so decarbonising processes that need high heat demand. We might see some in transport, specifically for like heavy goods vehicles. Another application for hydrogen would just be in just making like synthetic fuels, because things like the aviation sector, it's going to be really hard to decarbonize. And we did have 2 guest speakers on the previous episode who talked about their startup that was making a sustainable aviation fuel that uses hydrogen.
Yeah, that's the What Are E-Fuels episode.
Yeah. And another potential use of hydrogen in the future is actually in electricity. So renewable energy sources, so wind and solar, sometimes they produce excess or surplus electricity, so you need a way of storing it. An alternative to batteries is to just convert that electricity into hydrogen, and then we can use that hydrogen to generate electricity.
Yeah, I mean, that's a really good point. If you think about hydrogen and hydrogen bonds, they're some of the strongest bonds that exist. Actually, the use of hydrogen is to store energy. It's not as you would think of with fossil fuels, where it's a fuel where you just dig out the ground and there you go, you burn it. So yeah, that's the real way to think about hydrogen as well, is it's a way of transporting energy from one form to another and locking it in to use.
Obviously, energy is an increasing market demand for hydrogen, but it's not at the moment. So do we know what portion of hydrogen is used in the various different applications like chemicals versus metal.
Definitely petrochemicals. So ammonia, methanol would be the two biggest uses for hydrogen right now. They account for over 60% of the market right now for hydrogen.
That's actually lower than I thought. I thought it was all going to be for ammonia and then therefore fertilizer production. Would you call ammonia production petrochemical?
Ammonia, no, but hydrogen produced from natural gases would be classed under the umbrella of petrochemicals.
That makes sense to me. The one other use that we've not really mentioned is the use of liquefied hydrogen in space launches. I suppose because they make such a small amount of the demand for hydrogen, but maybe in the future it will be more common if we mine on the moon. But before we get there, let's talk about actually how are we producing hydrogen right now.
Currently there's like 4 different ways of producing hydrogen. The main one is from fossil fuels. So depending on if you use coal or natural gas, that can be called black, brown or grey hydrogen.
I think we should explain. So people have come up with this rainbow of calling hydrogen, kind of like people saying electricity from renewables is green electricity, even though it physically is not a different colour.
Yep.
Neither is this hydrogen is not physically a different colour. It's just the way that people have decided.
And the colours indicate a different synthesis route. If you add on carbon capture and storage to your fossil fuel hydrogen, and that then becomes blue hydrogen. The other ways of making hydrogen currently is using electrolysis. So again, depending on the type of electricity that you use, the colour can change. Renewable electricity, i.e. wind or solar, that can be called green hydrogen. Although if you use solar, it can also be called yellow hydrogen. There's lots of different colours and there's actually no consistency in some of the labelling. If you pyrolyze a hydrocarbon, basically pyrolyze biomass. So pyrolyze means is you heat it in the absence of oxygen. It's called turquoise hydrogen. The 2 ways of making hydrogen right now are in refineries. So that's usually your grey hydrogen or your blue hydrogen. And the other way of making hydrogen, it's a byproduct of the chloroalkali industry when you're electrolyzing sodium chloride solutions and you end up with hydrogen as a byproduct.
How do you get hydrogen from coal or fossil fuel?
In coal, you do something called gasification. So you produce a syngas. That's a mixture of carbon monoxide, hydrogen, and I believe some water vapor and some other gases in it. And you then just separate out the hydrogen from the syngas mixture. For natural gas, you do something called steam methane reforming, where you basically break the bonds between the carbon and the hydrogen. And I believe you also end up with some CO in that process as well.
And how do people separate these gases so effectively that you can get hydrogen separate from another gas that carbon monoxide?
You have something that's called a pressure swing absorption, which will separate out the hydrogen from other things that are being produced.
Is it they have different preferential absorption rates to an absorption medium?
Yeah, because it depends on the affinity for the different molecule and what the absorbent material is.
And that's a similar process for carbon capture storage, isn't it?
Yeah.
So you've got like one set to get the hydrogen and then you have another set to get the carbon monoxide / the CO2. If we didn't have that second step, we would just be emitting the CO2 into the atmosphere.
Yeah, basically.
So it's almost as if it's the same as if we burnt the fossil fuel, right?
Yeah, so that's why unabated, so without carbon capture and storage for coal or natural gas-based hydrogen is pretty bad, and that's why you want to add CCS onto it.
I guess that brings us on to why the green and pink/yellow hydrogen, the renewable and the nuclear electrolysis routes may be better.
Coming to what electrolysis is, what we're looking at here is breaking apart a water molecule to form your hydrogen gas and your oxygen gas through the use of electricity. Again, the strength of HO bond in water is really strong.
It's like abnormally strong. So it's quite a unique thing that water is liquid at the temperature and pressure that it is.
Yeah, definitely. That is what makes life on Earth water, and its interesting properties and extreme hydrogen bond networks that occur. So yeah, it's an interesting molecule, although it's very small and looks quite innocent. So yeah, so that's what the electrolysis is doing. And if you think about breaking apart a bond, basically you're providing energy to overcome the strength of that interaction. Now, there's two ways you can kind of go about that. You can either use purely electricity to power that electrolysis reaction, or you can add a little bit of heat in there, and that will weaken the bonds slightly, which means you need less electricity to break that molecule apart. Typically, when we do think about using some of the electrolysis methods in some of the other applications, so where we're using renewable electricity, or typically when we do think about nuclear electricity as well, it is just using just electricity and we're not thinking about any thermal properties. But with nuclear, especially as we move potentially to newer designs of reactors, such as high temperature gas cooled reactors, the idea is, well, we've already got really high temperatures going on. Why don't we take advantage of this? Instead of it being an unnecessary byproduct that we then need to deal with later, why not actually utilize it? So yeah, there's a lot of different potential designs of electrolysis technologies out there that could really utilize this. So at the moment, that's really steady research on alkaline electrolysis, where we slightly weaken the bonds with having potassium hydroxide or another alkaline solution, but essentially it's the electricity that breaks that water apart. But there's new technologies such as solid oxidized electrolysis that means that we can start using some of those thermal properties because we use steam instead of water.
Okay, so I was going to ask, what kind of temperatures are we talking when we say higher temperature water electrolysis?
That is a question to kind of solve of at what point does this all come together within a reactor design. But as long as we've got boiling water, that's what will help the process go, which is definitely very well achieved.
And how hot is a nuclear reactor or the high temperature nuclear reactors? Like just for a scale, like is it as hot as the sun?
With the high temperature gas cooled reactors, which is the technology that we're looking at to couple with, about 750, 950 degrees C. So you can see that's definitely going to produce steam.
Well, that's interesting. In traditional fossil fuel burning boilers, you can get heat recovery off the flue gases. But if we are losing that, then we kind of lost a source of heat in a way.
I guess the pro of thinking about moving to what is referred to as pink or yellow hydrogen with nuclear is that you can use the heat from that process and you can use the electricity directly from nuclear as well, or potentially from other sources if you so should want to, but the idea of coupling it is to use that electricity as well and it not produce CO2 like our fossil fuel plants would.
Is this something we could couple with small modular reactors, or is this like much more the large Hinkley Point C scale reactors?
Good question. I think the idea is if we're going to be coupling hydrogen production, it's probably going to be on a larger scale. It just makes sense of economy and the infrastructure needed to do it as well. It's probably much more sensible for our normal size Hinkley Point C reactor sizes, but I'm not ruling it out. I definitely can't say no to SMRs, small modular reactors, ever playing that role.
Yeah, I just bring it up because one of the challenges is where hydrogen is going to come from if we need it everywhere. And do we build hydrogen networks? Are we using hydrogen to transport hydrogen to then use elsewhere? Because hydrogen pipelines aren't a thing, like our natural gas pipeline.
Good question. I don't have an answer on the future of SMRs producing hydrogen, but it is that interesting thing of the economics of hydrogen production, of when do you use your reactor to make the hydrogen and when do you use it just to make electricity, and that is a big question to be answered when we're looking at the economics of using any process to make hydrogen, particularly from my background, nuclear. There's a lot of modelling that's been done on that from my team, but widely in the industry as well.
What implications do you think this has on the work that you're doing, Jasmine, with decarbonisation industrial hubs?
Could be something that could be more applicable or more usable for some industries, especially if they're located close-ish to a nuclear facility, because an issue with hydrogen is just how to transport it. There is quite a bit of research that's gone into how to transport hydrogen, and there's different ways that you could do it. Pipeline is an option, and there is actually work to convert gas pipelines into hydrogen pipelines, but you can also do other things like you could liquefy it and then transport it that way, or you could store hydrogen in things called metal organic frameworks, Or you can also convert hydrogen into what's known as a liquid organic hydrogen carrier, which is a chemical that contains hydrogen, which will release the hydrogen when you do make changes to the temperature or pressure. So there's lots of different ways of moving hydrogen, but right now, hydrogen is produced really close to where it's used just because transporting it's really expensive right now. But if we do see like a really big increase in demand, obviously there's going to be greater needs for both hydrogen production as well as ways of transporting it.
And the challenge with transporting it is because it's the smallest molecule that exists.
So if you have leaks in like equipment that's transporting it, that's a bit of an issue. But also hydrogen's a bit of a weird molecule because it has different properties to other gases. For most gases, the temperature increases when you compress it, but for hydrogen it's the opposite. It actually gets colder.
What?
Yeah.
No, I don't know why I didn't know that.
So pretty weird thing. But also the main thing about why hydrogen is going to be really tricky to transport is that it's a really dangerous gas.
Flammability?
Because it has a much higher flammability range than natural gas. So even at very low concentrations, it will combust, but even at very high concentrations, it can combust. I can't remember the exact range, but it's much higher than methane and other flammable gases.
And we found a way of making natural gas smelly so we can actually detect it a bit easier with a naked nose.
But the thing is, you need to find a chemical that doesn't react with hydrogen because hydrogen's very reactive, which is actually another issue for pipelines because...
They call it embrittlement, don't they?
Yeah, because hydrogen's really reactive, so you need to use a material that is not going to degrade from having to like carry hydrogen.
Just a whole host of complications to find the answer to.
Yeah.
That might be a future episode. So I suppose if we were to use nuclear... Do we call it thermochemical production, using the heat as well as electricity to break apart water into hydrogen? How far along are we with doing that? Because I've not heard of this technology before.
In terms of how ready this technology is to go on the market, it's not there yet. It's not something you can buy off the shelf and know it will 100% work, tried, tested with a nuclear power plant. So there's a lot of research that needs to be done there to kind of improve that as well. And yeah, so I think probably if anyone's familiar with these technology readiness gradings, TRLs, it's probably about a 6. So you can kind of see it's not at the point where you're ready to deploy.
Oh, so TRL 6, it's almost somewhere where people would invest in it because it's kind of proven enough. Technically it works, but the actual economics and making it physically happen is what needs developing.
Yeah, no, well, I definitely agree. I guess I just wanted to make the point. It's not something that you can buy off the shelf, but it's still some research, but we're at a point, yeah, where some exciting stuff could be happening.
TRL, or technical readiness level 6, that basically means you have a prototype system that works.
Yeah.
So TRL 7 would be an actual demonstration pilot plant, and then basically anything after that's basically you're going industrial scale.
Yeah, so it's not quite ready yet, but how do you think this will change energy use or chemical production if we did have wider scale hydrogen production?
Yeah, if we have more hydrogen, then there's going to be more ways that we can use it in the future. So currently, for the UK at least, it's predicted that most of the hydrogen is going to be used in industry as well as maybe a little bit in transport and electricity. But we could see it for other things. We could see more chemicals being made using hydrogen if we can get lots of green hydrogen or hydrogen from thermochemical splitting, because right now a lot of chemicals are based on fossil fuels. So we need a way of making chemicals that don't involve fossil fuels.
And this kind of links to our bio-based plastics episode, but we couldn't make plastic from hydrogen directly, could we?
No,
We'd have to convert it.
You need a source of carbon.
But it's possible.
Yeah, it's possible.
That's good.
Yeah.
And I think we touched on energy storage before, because hydrogen is kind of an energy storage medium as opposed to a direct energy source.
Yeah.
So I think one of the biggest challenges with the way our electricity generation is going is we have a lot of renewables which are intermittent in its production. If we have more nuclear, we have that base load energy, but anything to actually respond to peaks, what we call like demand response, we wouldn't have unless we had something like hydrogen and other storage methods, right?
Yeah, exactly.
Here's a question. If we talk about using hydrogen for high temperature stuff or fossil fuels for high temperature stuff, do you think carbon capture storage is going to develop faster than any of the greener ways of producing hydrogen?
That's a good question. Not sure. Like, there's already carbon capture and storage being used on industrial scales, and right now capacity is definitely a lot higher than what capacity is for electrolysis and green hydrogen production. But I think in the future there's going to be a lot more green hydrogen, but I think there will still be a place for CCS, but maybe not for fossil fuels, probably for bioenergy, just because in the run up to 2050 and you want to be net zero, you really do need to have phased out a huge chunk of your fossil fuel usage. So that means no more gas, coal and oil.
Yeah, I guess just to add to that, that if you're arguing that if we can get carbon capture, let's just carry on using fossil fuels, there's a lot more than just the CO2 emissions when you think about fossil fuels. It's the fact, do we want to keep digging these things out of the ground and more and more harder to do? So yeah, even if carbon capture does get to that great point, I think that we shouldn't be saying no to producing hydrogen in a more green or pink way.
Yeah, I think this is something we've not touched on, which is actually where's the water for electrolysis going to come from?
Yeah, that's a really big concern. That's something that needs a lot more research into, because you can use desalination for seawater because hypothetically there's lots of seawater, but then you have issues around that because like you need industrial scale in desalination, especially in places that have lots of renewable capacity but very little freshwater supplies, i.e. the Middle East. You could use other water sources, but then you'd be competing with other water uses, so like domestic water uses, industrial water uses, so you could end up with competitions for water resources. So it's something that really does need a lot more looking into.
Definitely, because I mean it comes to the economics of it as well. If you are doing desalination, then you're going to have the input energy to do that in the first place. Does it outweigh the energy that you produce?
Yeah, exactly.
And store in hydrogen? So
yeah, and I've heard that the purity of water also matters. Yeah. So we couldn't just directly use seawater for electrolysis. We have to remove the salt.
Yeah.
So we're basically competing for potable or drinking water.
Potentially, yeah.
Which is also a concern that people have for the future.
Yeah, I mean, it was also an issue with biofuels because it's like food versus energy. So now it's like water versus energy.
And I think that's it. When we first idea about hydrogen is, yeah, it's a very strong bond, so we're just using it to store energy, but the pro is water's everywhere. Like you said, the question is, well, is the right water everywhere? So, and then also, yeah, we produce a nice gas at the end that's can be cyclic and it's not going to produce any horrible other side products, but yeah, how do we transport it? So there's still some big questions on all that.
I think that was the perfect wrap up for this episode, Sophie.
Unintentional, but glad I did it.
And we might touch on this topic again in the future. Thanks for listening.
The views expressed in this podcast belong entirely to the person that said them. They do not represent any industry or organisation. If you enjoyed listening to these views, it would really help us out if you could rate us, leave a review and tell a friend. This podcast was sponsored by no one, but if you're interested in funding us to continue to have frank discussions about science and engineering, please get in touch.